Today we will be starting with the new chapter, that is the study of gas laws. So in this particular chapter we are going to learn about different gases which governs the behavior of gases. Okay, so turn to page number 114. So you have the chapter begins and in this page number. So you know what is a gas. First we need to know what is a gas to understand what a gas was. So gas is that state of matter where you have negligible force of attraction between the molecules and they are free to move randomly around the space in which it is kept. That means you have to remember here what the molecular force of attraction between the gas molecules is very, very weak, and because of that, now it can occupy the space which is given to it. Means they will be moving randomly in all the directions. Now there are certain characteristics of gas, and these characteristics you have been learning since your lower classes. So let us just recapitulate. Okay. So the first one is composition of gas. Gases are composed of tiny particles, and compared to the volume of the gas, these particles are negligible. Okay. The second one, gases, as I told you, they do not have their fixed shape or volume. So in whatever it is kept, it will occupy the shape and volume of that particular container. And this property is because of what? They have weak molecular force of attraction, and then they can move around randomly. The third, gases exert pressure in all directions. Since these gases are free to move in all the directions, therefore the pressure exerted by the gas will not be just in one particular direction but in all the directions. And gases are highly compressible and they can also be liquefied. Now as you increase the pressure, what will happen to the volume of the gas? The volume of gas will keep on decreasing, and finally what will happen? A state is reached where the molecules are bound to come very close to each other, and it will be liquefied, means it will be converted into liquid state. For example, the LPG gases that we use, there we have liquefied petroleum gas, you know it. And gases have low density. Why gases have low density? Because the molecules are very far apart from each other, therefore its molecular density is less. Now, let's discuss about what is absolute zero. Okay, so on page number 115 you have a definition for absolute zero. Please look at the definition. The temperature at which molecular motion ceases completely, then that particular, on the Kelvin scale, it has to be on the Kelvin scale, that particular point is known as what? Absolute zero. So the temperature at which all the molecular motion it ceases, means the molecules, they do not move, they become rigid, fixed, they do not move, and that particular temperature has to be in what? Kelvin scale, and that is known as what? Absolute zero. Now the behavior of gas, okay, the behavior of gas under known condition of temperature, pressure and volume is known as what? Gas law. So what is gas law? The behavior of gas under known conditions of pressure, volume and temperature is described by laws known as gas law. And here you have to remember there are these standard variables. Now see, there are three standard variables. And these are what? These are temperature, pressure and volume. So now these three standard variables will determine how a gas behaves, okay, under a particular set of these conditions. Now as you change any one of these standard variable, the behavior of gas also changes. So you have to remember what? Here there are three standard variables: temperature, pressure, and volume. And as you change any one of them, then what will happen? The other quantities will also change, and likewise the behavior of a gas will also change. Now, you know the temperature, the units. Let's discuss about the units. Temperature is measured either in degrees centigrade or Kelvin, and pressure mostly in millimeter or sometimes centimeter too. And volume, you know, it's given in centimeter cube, decimeter cube, and sometimes in liters. So these are the units of volume: centimeter cube, decimeter cube, liter. For pressure it is millimeter and centimeter, and for temperature it is degree centigrade and Kelvin. Now, for your numerical purpose, you have to know their relationship. Okay, so 0 degree centigrade will be equal to always 273 Kelvin. So you can interconvert if you know this relation between this degree centigrade and you have Kelvin. So this is the relation between degree centigrade and Kelvin. Millimeter and centimeter. Here mostly the standard pressure. Standard pressure is what? Pressure is 760 millimeter. Now this is equal to 76 centimeter. So remember this relation, okay? And here decimeter cube is always equal to liter. So these are the units of these different standard variables, and you need to know them properly. Because from this chapter you will be given numericals. Okay? So they have given you this definition of temperature, pressure, and volume. Please go through it. Now we will be coming to the first law, gas law, that is Boyle's law. So we are going to discuss about now Boyle's law. The first gas law is Boyle's law. And don't forget temperature, pressure, and volume. All these laws, whatever we are going to discuss about, okay, gases law. In that, you have to remember these are the state variables, and as they vary, there is, as any one of them varies, there is change in the quantity of other state variables also. So Boyle's law, what does it state? Boyle's law. So whenever you hear the term boil, so boil is like related to temperature. So every time you have to remember this way, that Boyle's law, in Boyle's law, temperature remaining constant. So temperature remaining constant. So Boyle's law, whenever you hear about Boyle's law, say temperature, boil is related with temperature. So temperature remaining constant. If this is constant, then how will these two vary? So from your common experiences, as you keep on increasing the pressure, what is going to happen to the volume? If you are increasing the pressure, what is going to happen to the volume? The volume will always decrease. Okay? So if you are increasing the pressure, the volume will always decrease. That means they are inversely proportional to each other. So what is inversely proportional? If any one of the term is increasing, the other one has to decrease. Okay? So inversely proportional means what? If any one of the quantity is increasing, like here pressure, when increasing the pressure, what is happening to the volume? The volume is decreasing. So you have to remember this. So temperature remaining constant, the volume occupied by gas is inversely proportional to pressure. So this can be denoted as volume is then the other term comes as denominator. So this is inversely proportional. Okay, the volume of a gas is inversely proportional to its pressure. At what? At constant temperature. Yes or no? So what do you get here? Now, as you remove this, let's take this to that side. V, let's remove this proportionality sign. Okay, V equals to some constant P. Then you can get it. If you take P to that side, then what will happen? PV equals to some constants. Okay, so this is constant. Now, this is actually is what? Boyle's law. So, in case of inversely proportional, whenever you have inversely proportional relationship, suppose you are taking in your book what is second in the x-axis, pressure is taken in the x-axis, and this side the volume is taken. And what is constant? Temperature is constant. K is constant. So in this case, you saw what? The volume is inversely proportional to pressure. So you get such kind of graph with a negative slope. So let's take any one point here. Say at this point. At this point, you see the pressure is this much and the volume is this much. Okay? So say this is V1 and this is P1 at this point. Say point A. Now let's take another point here. This is point B. Here the pressure is P2 and the volume is V2. Now you can see that here, in case at point A, you are having V1 which is lower than V2, okay? At this particular point A, the pressure is more than that of what? B. So here you can see what? With this side, the pressure is more. When the pressure is more, the volume occupied is less. And whenever the pressure is less, now see this point at point B, the pressure exerted is what? Less than that of A. But the volume occupied here is more than that of what? V, and more than that of V1, which refers to this point A. So you can see that with increase in pressure, the volume decreases. So you get such a graph whenever you are going to plot pressure against volume. So for your numerical purpose, this law will be used, and here two sets of conditions will be given. One will be the initial condition and the other one will be the final. Whenever such conditions are given, then you have to relate this. This P1 V1 will be equal to P2 V2. So this relation will be used for solving the numericals wherever what is mentioned as constant? Temperature. So whenever you see a numerical where temperature is said that it is constant, then you are going to use which law? Boyle's law, and this expression P1 V1 equals to P2 V2. This 1 means initial condition, and this P2 V2 means the final condition. So let's try out with the one numerical. Let's solve one numerical. So for numerical purpose, turn to page number 126. So on page number 126, you have numericals. Let's solve one of the numericals so that you will be knowing how to use this Boyle's law to solve the numericals. So, page number 126. Question number, let's say question number 7. So, what does the question number 7 tells us? 561 decimeter cube of a gas at STP is filled in a 748 decimeter cube. So, decimeter cube is the unit for volume. So, we can take it as what? V1, the first one is V1, 561 decimeter cube, and the second one 561 decimeter cube, and the second one is 748 decimeter cube. So the second one is B2, that is 748 decimeter cube. Okay? So this is the initial condition of volume and this is the final condition of volume. And they have told us what? 561 decimeter cube of a gas at STP is filled in a 748 decimeter cube container if temperature is constant. So here you have to remember, if temperature is constant, which law you have to apply? Boyle's law. What is constant? Temperature is constant. Okay? Temperature is constant. And they have given you what? Calculate the percentage change in pressure required. So they are asking you to calculate the percentage change in pressure required. That means initially they have given us this condition, STP, standard temperature and pressure. Standard temperature and pressure. So here, by saying us that STP, they have already given us pressure indirectly. So pressure, standard pressure is taken as P1 and that is 760 mm of mercury. Please you have to remember standard pressure is what? 760 mm. Okay? If you want to write it in centimeter, it will be 760 centimeter. So they are asking us to calculate the percentage of pressure change. Yes or no? So they are asking us to calculate the percentage change in pressure required. So at first, what we are going to do is we have to get this pressure P2. After that, we can calculate the percentage change. So here, all these are the given quantities, and once you write the given quantities, you will be knowing which law to use. Here, Boyle's law, why temperature is constant. So Boyle's law, according to Boyle's law, what we have? We have P1 V1 equals to P2 V2, and we need to calculate P2. So to calculate P2, say P2, then P2 will be equal to P1 V1 by V2. Now put the values. This P1 V1 means P1 is multiplied with V1, P2 is multiplied with V2. Okay, so let's put the values of P1. P1 is how much? 760. And V1 is 561. And what is V2? V2 is 748. 748. So after calculating this, you can calculate it by yourself. Calculate it. After calculating this, you will be getting a value as 570. 570. And since you are calculating pressure, it has to be in millimeter. So you got P2. You got the P2 value. Now, what the question has asked us? The question has asked us to calculate the percentage change in pressure required. So let's calculate first what is the change in pressure. So change in pressure equals to initial pressure was 760, and what is the final pressure? That is 570. So two pressures. Change in pressure means what? You have to subtract the pressure from the initial pressure. This is the final pressure that you want. It has to be subtracted from the initial pressure. So whenever you subtract it, you get 190 mm. So now you got the change in pressure. But the question has asked for us to calculate this in percentage. So let's calculate. Percentage change in pressure will be equal to. Now how do you calculate your percentage? You have to take whatever marks you have obtained divided by the total marks into 100%. Here also it's the same logic is applied. Here percentage change in pressure will be equal to, this is the change in pressure, so 190 divided by the total pressure 760 into 100%. So if you cancel out this terms, then you will be getting 25%. Okay, so this is how we apply Boyle's law to solve the numericals. This is very simple. Out of the 4 things, P1, P1, P2, P2, 3 things will be given. 3 quantities will be given. You need to just calculate the 4th quantity. And you have to be very careful with regard to their units. Whenever you are calculating, the pressure, they have to be in the same unit. Volume, they have to be in the same unit. Please take care of that. Okay? Whenever you are doing the calculations. So in our next video, we are going to discuss about Charles' law. Till then, please practice these numericals. So number 7, I have already done for you. Number 4, number 5, number 6, and number 8. So these are the problems that you are going to solve at your home. Okay? 4, 5, 6, and 8. 7 is already solved. Thank you.